Okay, so we're dealing with law of sines and case 2 where you have two sides and one opposite angle. These examples, we'll do 2, is when you end up with just one solution. Now if you run your tests, and this is the fastest test there is, if A is greater than B, you will only have one solution. Now what does that mean? Well, we're assuming in this situation that angle A is the angle you were given, side A is the side that was opposite that angle, and side B is any other side in the triangle. So if your side that's across from your given angle is bigger than that other side they gave you, you'll automatically know you have one solution. Okay. If you don't test it, I'm going to show you how you'll know that there's just one solution anyways.
But it takes a little work. All right, so if this is our given question, notice we have case 2. We have two sides, and we have the angle opposite one of those sides. So if we were to draw ourselves a little diagram, and this just helps to keep track of where everything is. Side length A is 22, our side across from B is 12, and we don't know C. Our angle A is 40 degrees. So if we do our quick check, and we notice that the side across from our angle is bigger than the other side, then we know we have 22 greater than 12, A greater than B, so we have one solution to this problem. So if you're on your test beforehand, you know this is only one solution. Now if you didn't run that test and you just started solving, you'll still be able to figure out that there's just one solution. It just takes some work. All right, so use law of sines. We have A and A, so that's what we're going to start with. We have one of our B's, so we're going to start by finding the angle B. Put in your information that you know. We know A is 22. The sine of the angle A, which was 40, equals B, it's just 12 over the sine of angle B, which I don't know. So to solve, we're going to cross multiply, and we get 22 times the sine of B equals 12 times the sine of 40. I'm trying to get B by itself, so I'm going to divide by 22. And now I have sine B equals 12 times the sine of 40 divided by 22. Okay, we're going to do the inverse sine to solve, but first I'm going to go ahead and calculate that to make sure that it's something I can take the inverse sine of. All right, so I get sine B is 0.3506. So we know we have a solution because our number is less than 1. So we take the inverse sine to get B by itself. And I get B is the inverse sine of 0.3506. And again, I just leave that entire number in my calculator, so I'm not rounding, but you should get something close to me, even if you round it. You should get close to 20.5. So we found 20.5 for our angle B. But we know, since we just did inverse sine to find that, if we hadn't have done the test, okay, let's say you didn't do the test. Let's say we found angle B is 20.5, and then we remember, oh man, if there's an angle with a sine of 0.35 in this quadrant, there's also one in quadrant 2, okay, and it would be 20.5 degrees away from that x-axis. What would that angle be? Well, 180 minus 20.5. Okay, and we get a 159.5 degree angle. The problem is, if you said, oh, there's B, that could be an answer also. But if you tried to find angle C with that angle, it would be whatever angle is left in the triangle. So if we said that's 159.5, triangles have a total of 180, and I have a 40 degree angle, and I have a 159.5 degree angle, and we subtract that, we get -19.5. So we know that that alternate angle was too big. okay? It would have worked because it had the right sign, but it doesn't work because it's too big and makes our angles in our triangle go over 180. So if you don't run the tests, that's how you'd know you had one and not two solutions for this one. Okay, so in this case we only have one solution, and for that solution angle B will be 20.5. So now we're going to find C and lowercase c. We're going to start by finding angle C and take out that incorrect B. Okay, and this seems overwhelming, but you don't have to do all of these. You can either test beforehand or you can check the angle afterwards. Okay, but we know our B is 20.5 now because the other one didn't work out. So we want to find angle C. So we subtract the 40 and the 20.5 to find out how much is left. And there are 119.5 degrees remaining in that triangle. So we know angle C would have to be 119.5. And we have one thing left to find. Okay, so if we find that lowercase c, that's all we have left. We're going to go ahead and go with our given values, a and sine a. So we have 22 of the sine of 40 equals c over the sine of 119.5. We just found that angle. How are we going to solve? Well, all we need to do is get c by itself. So if we just multiply both sides by 119.5, we will accomplish that. All right, so c is 22 times the sine of 119.5 divided by the sine of 40. And I get about 29.8. And we have solved this triangle. We found all the missing parts. It only had one set of solutions, so we are done. I'm going to do one more example.
I'm going to do one more if you want to pause and try this one on your own and then check it. That's sometimes a good trial to see how you're doing. Here is, again, we're given case 2. We're given two sides and the angle opposite one of those sides. The quick check is, here's our angle. The side opposite that, which happens to be B this time, is bigger than the other random side they gave us. If that is the case, then there's only one solution. You don't have to do the B times the sine of A, or in this case it would be C times the sine of B. Okay, if this number across from the angle is bigger, there's one solution every time. Okay, now here we go. This is with law of sines. I'm going to draw a little diagram. Okay, I know angle B is 30 and that the side opposite that little b is 20. I know that the side opposite angle C is 16. I don't know angle A. I don't know the side opposite angle A, and I don't know angle C. We're going to start by using the law of sines, and we're going to start with the two given values we have. We know both of, and that's the b's. So we'd go b over sine b equals, and we're going to try to find one that we have one of the values for the pair. So we know the c, so we're going to do c and sine c. We keep going, so put in our values. 20 over the sine of 30 equals c, which was 16, over the sine of c. This time we have sine c, we need to get by itself. So we cross multiply so that we can get it out of the denominator. And that gives us 20 times the sine of c equals 16 times the sine of 30, and then divide both sides by, excuse me, I should have started on this side here, by 20, so that we just have the sine of c. And remember, if you're not doing any testing at all at the beginning, you would know this one is no solution if I end up with a number bigger than 1 right here. Because that would be saying I have a sine bigger than 1, and that's not possible. But that's not what happens. We end up with the sine of c equals 0.4. To find the angle measure, we do the inverse sine of both sides. And when we do, we get about 23.6 degrees. Okay, so I know C is 23.6. When you're using the law of sines to find a missing angle, though, and you do an inverse sine, you have to remember, I tested
Now, I tested this at the beginning, and I know there's only one solution, so I shouldn't have to do this. But if you're not planning on running tests and you're trying to figure it out, you will need to check this to see if there are two solutions. So I know that the sine is 0.4 at 23.6, but I also know that there's an angle 23.6 away from the x-axis that also has that sine of positive 0.4. Well, what would that angle be? We take 180 minus 23.6, and we get 156.4. So if you thought there was a possibility of two solutions, and you try to set up your second case, you're going to figure out that it doesn't work. Because if angle C happened to be 156.4, and you try to find angle A, we'd take 180 minus the 156.4 and the 30 that we already have for angle B. Okay, we're trying to check what it would be based on the total of 180. We get negative 6.4. So if 156 were a possibility, it takes our triangle over 180. Okay, it had the right sine value, but it's not going to work for a triangle. Okay, so we do have one solution. So if you test at the beginning, you know you only have one and you don't have to go through that process. But if you're not testing at the beginning, you do need to check later on to see if there's a possibility of two solutions. In this case, we only had one. So we're going to go ahead and go back over. We know C is only 23.6. And we're going to find our third angle, angle A. It's whatever left over in the triangle. So if one is 23.6 and the other is 30, how much is left for angle A? That leaves us with 126.4 degrees. Okay, so angle A would have to be 126.4. And we have one more thing left to find. We need to find side length A. So again, I'm going to start with the two values I was given so that there's no rounding and it's most accurate. So I have B over sine B, which is 20 over sine 30, equals A, which I don't know, over the sine of angle A, which happens to be 126.4. We want to go ahead and solve this. So A is on top, so all I have to do is multiply both sides by 126.4. And then I will have my answer that A is 20 times the sine of 126.4 all over the sine of 30. They get a little messy. I'm sorry, this page gets pretty full with all these steps. But we get A is about 32.2. So we've solved the triangle. It only had one solution, and we have all of those parts we need.